This is page 80 of your math journal. We're going to give this one the title of Equivalent Expressions. All right, let's write the definition for equivalent expressions here. Equivalent means to be equal. So we're talking about expressions that are equal to each other in value. Okay, so equivalent expressions, let's write expressions that are equal to each other when they are simplified. Okay, so how do you determine that? Well, let's look at some numerical expressions first. So example, if I have 5 plus 3, or we have 4 plus 4, or I have 10 minus 2 plus 1 minus 1. Okay, those are all expressions. This one, though, when you're done with it, it simplifies to 8. So does this one. 10 minus 2 is 8, plus 1 is 9, minus 1 would be 8. Once again, this simplifies to 8. So at the end of the story, its value is 8. These are equal to each other. So these are equivalent expressions. Same things works with algebraic expressions. Okay, let's say we have 3x plus 2. We have 4x minus x plus 2. Or we have 3 plus 3x minus 1. Okay, so they're all differently written expressions right now. But when we simplify them by combining like terms or distributing or any of those, if they end up being the same thing in the end, they are equivalent. So this one, I can't simplify anything. These are not like terms. I have no distributing to do. So 3x plus 2 is the exact same. Here I can put these like terms together. So 4x minus x, that gives me 3x. Plus 2. So those are equal to each other. I have the exact same things in its most simplified form. Okay, up here I can combine 3 and minus 1. 3 minus 1 is 2. Plus 3x we already have. Alright, looking at these, their order is just swapped. However, they are equivalent due to the commutative property. So that's how you can know if you have equivalent expressions. If they simplify to the exact same thing, including the symbols. One thing that might fool you is sometimes you might simplify and end up with 3x minus 2 and think, oh, I got 3x and I've got 2. Watch your symbols. Minusing 2 is not the same as adding 2. However, these ones are all the same. Okay, we're going to try and see if some of these expressions are equivalent to each other. So, compare the two expressions. Compare the expressions and see if they are equivalent. Okay, just a reminder, the two ways that we simplify by combining like terms and distributing. All right, so we have 3x plus 4 minus x plus 7. Over here we're going to have 11x plus 6 minus 4. Okay, here we have no distributing to do, so we're just going to be combining like terms. So I'm going to combine 3x and x. That's going to give me 2 x's. I can combine 4 plus 7. 4 plus 7 would be plus 11. So I have 2x plus 11 here. Okay, simplify what we can here. The only like terms I have are my constants, so I'm going to put those together. So 6 minus 4 is 2. So I have 11x plus 2. Now here's where it's going to catch you. A lot of people say, oh, I see a 2 and I see an 11. They got to be equivalent. No. This has 2 x's. This one has 11 x's. This one has 11 constants and this has 2 constants. These are not the same. So these ones are not equivalent. Okay, let's try another set. 3 parentheses 2x minus 6 plus 15. No. Yeah, 15x. Okay, and then I want 7 parentheses 3x plus 2 okay, so in the parentheses we have 3x plus 2, and then I want you to write minus. Alright, I'm changing this around a little bit. I want you to write minus 2. Over here I want you to make this a plus 6 for me. Okay? Alright, so now that those are changed, let's go ahead and simplify. Okay, order of operations says we have to do our multiplication first. That's what we do when we distribute. So we're going to distribute first to simplify. So this right here would be 3 times 2x. Don't get confused and forget to do it to the other thing. To distribute means to share equally. We are sharing that 3 with both terms. So plus 3 times 6 plus 15x. So 3 times 2x would be 6x's plus 3 times 6 would be 18 plus 15x. Okay, combine like terms. Now this is where we're just adding and subtracting, so see how we did our multiplication first. Now we're doing our addition and subtraction. So I'm going to put 6x and 15x together. That would give me a total of 21x plus 18. All right, over here, 7 times 3x plus 7 times 2 minus 2. Okay, 7 times 3x would be 21x's plus 7 times 2 is 14. Minus 2, I'm going to combine like terms here. Adding 14 minus 2, at the end of my story, I have 12. So this is 21x's plus 12. Okay, I have 21x's. That part's the same. However, adding 18, adding 12, those are not. So once again, this set is not equivalent. Okay, let's try one more example. I want you to do 2 parentheses x minus 7 and we're going to do 3x plus 4 x minus 5 minus 5x minus 9. Okay, we're going to combine like terms or distribute to simplify. So here we only have distributing, so 2 times x minus 2 times 7. This would give me 2x here minus 14. So I get 2x minus 14 here. I can't do anything more. These are not like terms, so I can't combine them. Okay, over here, combine like terms. 3x plus 4x minus 5x. Okay, so 3x plus 4x would be 7x. And then 7x's minus 5x's is going to end up with 2x's. All those combined together to make this. Now here you've got to think, I'm minusing 5 already. I would just write minus 5 if that was it. But then I'm minusing 9 more. So if I'm minusing 5, and then I minus 9 more from that, so minus 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 9 more minus is minusing a total of 14 by the time the story is over. So, now looking at this, these combine together. You have to watch your signs because they were subtracting. 2x minus 14 is the exact same as 2x minus 14. So these are equivalent to each other. If you want to prove it, another way you can do it is by plugging in a number and seeing if it works. So one example of what I could do is if I wanted to plug in, okay, watch what I'm doing, just to prove to you that they are equivalent. If I say, well, I want x to be 3. So if I put, let's do something that I can minus 7 from. Let's make x 9. If I put in 9 here, I get 9 minus 7, which is 2. So 2 times 9 minus 7. See what I'm doing? Just plugging in something that will work in there. 9 minus 7, do my parentheses first, would be 2. And then I have 2 times 2, which is 4. Okay, over here, if I do the same thing, I'm going to have 3 times 9, 3x, plus 3 times 4, minus 5 times 4, or 9. I don't know, I put a 4 there, I'm sorry, that's a 9. 4 times 9, there we go. Okay, check that. So 4 times 9. So this is me proving that they're equivalent. So this would be 5 times 9 minus 9. See, all I've done is put in x, 9 where x is. I put 9 in this one over here, and I got 4. We put in 9 here, and we're going to see what we get. Okay, multiplication. I have to do that first. So this would be 27 plus 40, or 4 times 9, which would be 36. Minus 5. Minus 5 times 9 is 45. Minus 9. Okay, if I add these together, order of operations, we're going left to right. 27 plus 36 is 63. 63 minus 5 minus 45 minus 9. So 63 minus 5 gives me 58. 58 minus 45 gives me 13. So this gives me 58. 58 minus 45 gives me 13. And then 13 minus 9 gives me 4. So right there is another way you can prove that they are equivalent. I just picked a number for x to plug in there, so I could easily work it out. And it shows me that they are equivalent even when I put numbers in for them. So we can check it by seeing if these match up, which I personally think is easiest, but if you're still questioning it, you can put a number in. We put in 9, and you can solve it out and make sure that they both work. No matter what, though, here you can see that they are equivalent to each other.